Example 2 for elimination. As I run through these examples, notice that the equations are always in standard form. That's not necessarily a requirement, but it pretty much is a standard for the way that you're going to solve these equations. You want them in the standard or general form so that you can look and determine which variable you want to eliminate. You cannot, I repeat, you cannot have one in standard form and one in slope-intercept form. That's something more designated only for substitution. So as we use this elimination method, we have to decide, do we want to get rid of our x's or our y's? Arbitrary choice. For this problem, I think I'm going to get rid of my x's. And so I'm going to look at equation 1 and equation 2. And what I have to ask myself is, how can I make these equal but opposite? You're allowed to multiply one equation, or you're allowed to multiply both equations. In this case, the first number that both 3 and 4 will have in common is 12. So I think I want to transform the equations so that one equation is positive 12x and the other is negative 12x. That's easily achieved by taking negative 4 times equation 1. And then for equation 2, I can simply multiply that by 3. Notice this notation to the side. I talk about what equation I'm working with and what I'm doing to transform it. As I transform the first equation, I'm simply going to multiply by negative 4. Negative 4 times 3 is negative 12x. Negative 4 times 5 is positive 20y. Negative 4 times 8 is negative 32. I move to the second equation. 3 times 4 is 12x. 3 times negative 7 is negative 21y. 3 times 10 is 30. Once I've achieved equal but opposite coefficients, I'm permitted to combine the equations. Sometimes elimination is called linear combination because this step here, you combine the two lines. Linear combination, when I add this up, the x's drop out. 20y, take away 21y would be a negative y. Negative 32 and 30 would be negative 2. That means that if negative y is negative 2, positive y must be positive 2. Now I'm half there. I have one of the ordered pairs, so I'm guaranteed that the two lines must intersect at a point. I can find the x value by simply taking this y equals 2, and plug it into any of these equations. I think I'm going to go to the first equation, and as I go to the first equation, I can say 3x minus 5 times 2 equals 8. Now as I solve that, this would be 3x minus 10 equals 8. If I move the negative 10 over, 3x would equal 8 plus 10, which is 18. And then I can divide by 3. As I divide by 3, 18 divided by 3 is 6. Looks like I get a nice answer here of 6, 2. Again, the concept for elimination. You have to pick either the x or the y to eliminate, and then you want to make those coefficients equal but opposite. And that's what I've done in this example. You do want to make sure that your equations are in standard form, and then everything should work out fine for you. Example 2, elimination.